An exciting day starting with slant asymptotes. Now remember, if the degree of the numerator is one larger than the degree of the denominator, we know that there is a slant asymptote. Okay, as long as the remainder is not 0. All right. In this case, we can find the slant asymptote by doing long division. All right, but we'll start off at the beginning. First, we're just going to find the limit as x approaches infinity of our function. Now remember, it's going to grow faster at the top than it is on the bottom, so that's going to be infinity. Part B, the limit as x approaches negative infinity. Now we just plug in our negative large numbers. The top's going to be a positive infinity, the bottom's going to be negative infinity, so our limit is negative infinity. Find any and all asymptotes. Okay, so now, do we have a horizontal asymptote? Well, since we put in infinity and negative infinity, and we got infinity and negative infinity, we didn't get real non-infinite numbers. There are no horizontal asymptotes. Vertical asymptotes, that would occur where the denominator is 0. So where this equals 0. So there is a vertical asymptote at x equals positive 1/2. And we also have a slant asymptote, and we can get that by doing long division. Okay, so if we do 2x minus 1, we have 6x squared plus x plus 7. Okay, 2x times 3x will give us 6x squared. Minus 3x, change our signs. I get 4x plus 7 plus 2. All right, so that's the last thing that's going to go evenly. All right, and then we have a remainder. So this gives us our slant asymptote. There we go. So we have all of those. All right, now this is a little bit different. It's not as easy to see the degree of the numerator or the degree of the denominator. In this case, they are the same, because if you took the square root of just this term, we would get 3x. Now, since that is the same degree as the numerator, we can apply our rules. So really what we're thinking is we're doing 4 times a very big, large positive number over the square root of 9 times a really big, large number. So it turns out that this limit is equal to 4 over 3. Square root of 9 and infinity squared, so square root of that would be 3 infinity, which is the same degree as the top. The only thing that changes when you plug in negative infinity is it may be the sign changes. So in the top now we get a negative 4, and in the bottom we're still going to end up with a positive 3 times infinity, which makes it negative 4 over 3. Alright, so part C here, the degrees will be the same because the square root of 11, that's x squared cubed, or x cubed squared. Okay, so that's going to be the same degree as we plug in a very large a very large number. We get negative 2 over square root of 11. We'll just leave it in that form. Okay, here it appears that the degrees will not be the same. The degree in the denominator instead is like x cubed. Okay, since that's larger than x squared, the bottom will grow faster, and this will instead approach 0. Okay, these are good problems to know. You need to know how different things grow. Okay, like log functions are very slow. Polynomials then grow, like x squared grows slower than x cubed or x to the 4th, etc. Exponential functions grow faster than a polynomial. Okay, 2 to the x, something like that. Factorials grow even faster, especially something like this. Okay, the king of growth is x to the x. So let's analyze these. The first one, x cubed, or an exponential. Now, exponentials grow faster than any polynomial, so then the bottom grows faster, this approaches 0. All right, part B. The top is a constant. The bottom is a function. The function is going to grow faster. Okay, this one, this would grow or equal 0. Okay, as we try the next one. Log functions grow very slowly. Polynomials grow faster. The bottom is growing faster. This equals 0. Okay, we have an exponential over the king of growth. 0 again. How exciting. All right. I want you guys to try the next couple. I'm going to go over one that I think may be tough. That would be letter I. The other ones you can do, and we'll discuss them in class. But letter I can be kind of tricky. So just plugging in a number, you're not going to get anything usable. If you do a little bit of algebraic manipulation, however, it looks pretty nice. So what we're going to do is add, or we're going to multiply by the conjugate. Okay, and then we have 4x minus. And remember, we can multiply anything by 1, so we're not changing it. All right, now we get 4x times 4x. That gives us 16x squared in the numerator. 16x squared. And minus 16x squared minus 3x in the numerator. Okay, in the denominator, we would get 4x minus square root of 16x squared minus 3x. All right, so now take a look at what we have in the top. We have positive 3x over, and we get 4x minus square root of 16x squared minus 3x. If we try to plug in infinity now, we're going to have 3. Oh, it's negative infinity. So we'll have negative 3. This part will be the 4x. That'll be negative 4. And everything's the same degree here. Minus, we have 4 times another positive infinity. So we get negative 3 over negative 8, which really gives us a simple 3/8. That one's the most difficult, but I think you could do the rest. Let's see. I'll save the last topic for one more video, as long as you try each and every problem. And let's see. I want you to put letter H in your whisk. Have a great day.